Hello friends, welcome to the video lecture series of Engineering Mathematics 1. As per the standard way, we are not going to discuss MCQ. Some explanatory problem we will be discussing, and time to time I will be telling you which type of MCQs will be asked in examination. If examination is offline examination, in that case the whole problem or solution of the problem you have to give, you have to present. Part of the solution may be asked for as MCQs. Yes, first of all, what is Rolle's theorem? The Rolle's theorem, in short, I tell you, the Rolle's theorem requires continuity in closed interval, differentiability in open interval, and function of A, f of A equal to f of B. F of A equal to f of B means what? The value of the function at end points of the intervals must be same. This is a statement of Rolle's theorem. If the function fx is defined in closed interval and fx is continuous in closed interval, differentiable in open interval, third condition is function of a equal to f of a equal to f of b, means value of the function at a, value of the function at x equal to b, these two are same, then there exists at least one point, in open interval AB such that the derivative of the function fx at x equal to c is 0. F dash c equal to 0 means what? Derivative of the function at x equal to c is 0. So geometrically, I explained this. This is y-axis, this is x-axis, and this is the curve, blue curve I have drawn. And these are the end points. The function is defined, this curve is defined on closed interval AB. And f of a, function at x equal to a, value of the function at x equal to b is same. See, this is same. And C is the point somewhere in between A and B. It is in open interval such that the derivative of the function at x equal to c is 0, means slope of the tangent, derivative geometrically is slope of the tangent to the curve, slope of the tangent to the curve at x equal to c is 0, is it? See, in open interval the end points are not included, but in closed interval end points are included. Closed interval is written like this and open interval is written like this. Now, the first problem, verify Rolle's theorem for the function. This function is given and this function is defined in this interval, minus root 2 to root 2, and this is closed interval. So what is our first job is to find out f of minus root 2 and f of root 2. F of a and f of b we have to find. So put x equal to minus root 2 and calculate it, it is coming to be 0. F x equal to root 2, then calculate it and it is again coming as 0. The f of a equal to f of b. This function is polynomial function. Polynomial functions are always continuous and differentiable. Okay, but it is not necessary to show or it is not necessary to prove the fx is continuous in closed interval, the fx is differentiable in open interval. You can straight away you can write. In MCQs about the continuity and differentiability may be asked. Then in MCQs the value of c is asked. The c is what? C is the point which is in between a and b. How to find out the value of c? Take derivative of this. Derivative of 2x cube is 6x square, derivative of x square is 2x, derivative of x is 1, derivative of minus 2 is 0, like that. Then put x equal to c, replace x by c, this is f dash c, and value of f dash c I am considering it as 0 because we want value of c. Then this equation is equal, this is equal to 0, and this equation we are going to solve. The two values of c you will be getting, but I would recommend you to use calculator to get the values of c. And here I don't have calculator right now because Therefore, I am solving it this by traditional way, analytically, like this. The C equal to -1 and C equal to 2 by 3. Two values of C we have obtained, and at least one value of these two must be in open interval. So this is the open interval, okay, -√2, and this is the open interval, and C equal to -1, C equal to -1 somewhere here, and C equal to 2 by 3 somewhere here. So these two values belongs to open interval. These two values belongs to open interval AB, or √2 minus √2. Therefore, the Rolle's theorem is verified. But in MCQ, what you will be asked? You will be asked to find out value of C. Function will be given, interval will be given, and you will be asked to find out value of C. Okay. Similarly, second. See, second function is also a polynomial function. You can directly write function is continuous in closed interval, function is differentiable in open interval. F of 2 means f of A you can find, f of B you can find, and these two are same. Third condition is also satisfied. For finding value of C, take derivative of this is derivative, put x equal to C, f dash C I'll get, and f dash C, put f dash C equal to 0, 2C minus 6 equal to 0, therefore C equal to 3. Now you check whether this value of C belongs to open interval or not. This is open interval 2 to 4, and 3 is lying somewhere here, and 3 belongs to the open interval. 3 belongs to the open interval 0, 2 to 4. Therefore, the theorem is verified. Now, similarly, third problem. This is the function. This is interval. This is polynomial function. Since the function is polynomial, you can directly write function is continuous in closed interval, function is differentiable in open interval. F of -2, f of 2 you can find out by putting x equal to -2 and x equal to 2 respectively, and in this way you will be getting values of f of 2 and f of -2, and they are same. I have written directly. For value of C, take derivative of this is derivative of fx, put x equal to C, then 3c square equal to 4, c square equal to 4 by 3, and C is equal to under root of 4 by 3 is plus minus 2 by root 3, and plus minus 2 by root 3 is lying in open interval 2 to 4. This is open interval 2 to 4, this red bracket open interval, and C is equal to 2 by root 3, C is equal to minus 2 by root 3 somewhere here. Therefore, C belongs to the open interval. C belongs to the open interval 2 to 4. Okay, theorem is verified again. Next problem. This function is given to you, interval is given. Here in this function, the transcendental functions are given. Transcendental function means what? E raised to power x, or exponential function, sine function, trigonometric function, log functions. Okay, inverse trigonometric function. It comes under transcendental function. Fx is given. Now sine function, cos function, exponential function. Sine function, cos function, exponential functions. These are continuous and differentiable. So you can straight away write function fx is continuous in closed interval, function fx is differentiable in open interval. Then f of a you can find, f of b you can find, put x equal to pi by 4, 0 you are getting, put x equal to 5 pi by 4, use calculator and get the value which is 0. Means f of pi by 4 is f of 5 pi by 4, these two are same. Three conditions are satisfied. Find value of C. For value of C, take derivative. I have taken derivative using product rule, u into v rule, because we have the product of two functions in each of the term. Then so after simplification, these two terms are going to get cancelled after taking derivative. So this plus this, 2 times of this, and f dash x is this one. Put x equal to c. If you put x equal to c, then 2 e to the power c, sine of c is there, and value of f dash c, I am putting 0 because I want value of c, and product of these three element is 0. 2 is not 0, a raised to power c, exponential is never to be 0, therefore sin c must be 0, and sin c equal to 0, therefore c equal to sin inverse of 0, and this is multi-valued function, you will be getting multiple values of c. The c is 0, c is pi, c is 2 pi, because these are the values of sin inverse 0. At least one value must lie in our interval. Our interval is what? Pi by 4 to pi 5 pi by 4. And this red bracket is open interval. And one of the value, means 0 is not coming under the open interval. But pi is coming over here. Pi belongs to the open interval pi by 4 to pi 5 pi by 4. Therefore, theorem is verified. Okay, the value of c is maybe asked in online examination as MCQ. Now, the fifth problem. Here function is given. Exponential functions and polynomial functions are continuous and differentiable. Therefore, in straightforward way, you can write continuous in closed interval, differentiable in open interval. Then f of minus 1, f of 1 you can find out. F of minus 1 is 1, f of 1 is 1. Therefore, these two are same. F of a equal to f of b. Three conditions are satisfied. Now we want c, value of c. Take derivative. I have taken derivative. Put x equal to c like this. Then f dash c equal to 0 and f dash c is 0. An exponential function, this is never to be 0. Therefore, and minus 2 is not 0. The c must be equal to 0. The c equal to 0, you please check whether it is coming under the open interval minus 1 to 1 or not. Open interval c is somewhere here, minus 1 and 1 in between, minus 1 and 1. C belongs to minus open interval minus 1 to 1, therefore it is verified. The value of c may be asked in as MCQ. Next problem, fx equal to tan x. See, some typical functions are in Rolle's theorem. I will recommend you to remember the function. Tan x equal to, because if you check the continuity, it will take more time, and when you solve MCQs, for MCQs, the explanation is not required. Even if you remember, it will be more economical. The tan x function, it becomes infinite at x equal to pi by 2. Means tan pi by 2 is infinity. Means in this, and pi by 2, 0 to pi is the interval, and x equal to pi by 2 is somewhere here. And at x equal to pi by 2, tan function becomes infinity. Therefore, function is not defined at x equal to pi by 2. If function is not defined at x equal to pi by 2, so it will not be continuous and differentiable. It will not check the continuity and differentiability. We want continuity at each and every point of the closed interval. We want differentiability at each and every point of the closed interval, open interval. And at one of the point, function is not defined. Therefore, it will not be continuous or differentiable like that. Therefore, theorem is not verified. Rolle's theorem is not verified. Okay, in online examination, the question may be asked like this: the following function does not satisfy the Rolle's theorem or conditions of Rolle's theorem, and some functions will be given, and rest of the functions will satisfy the Rolle's theorem. And if tan x is one of the option, then you can select the tan x, because tan x does not satisfy the Rolle's theorem. Here fx equal to mod x. The mod x function is defined like this. The interval is minus 1 to 1. This minus 1 to 1. The mod x function is defined like this. For 0 to 1, mod x is x, and for minus 1 to 0, mod x is minus x. Okay. In this way, the mod function is defined, and theoretically, mod function is continuous. Mod x is continuous in minus 1 to 1, but it is not differentiable. It is not differentiable. Okay, at this point, at x equal to 0, it is not differentiable at x equal to 0, and we want differentiability at each and every point of the open interval. Each and every point of the open interval. But at x equal to 0, which x equal to 0 lies somewhere here in between minus 1 and 1, the function is not differentiable at x equal to 0. Therefore, Rolle's theorem is not satisfied. The differentiability may be asked as in online examination. The function fx equal to mod x is not differentiable at x equal to 0. This MCQ, this type of MCQ may be there in examination. Now next problem here, this is the function given, numerator by denominator. Okay, numerator itself is a polynomial, denominator itself is a polynomial, numerator and denominator are continuous functions. Okay, but when denominator occurs, then you have to look at the interval. This is important. See, for this interval means what? 0 onwards up to 4. 0 onwards up to 4 means 0 or positive. For 0 and positive x, denominator is not going to become 0. Denominator is not going to become 0 for these values. Therefore, function is okay for this interval. Find value of f of a, find value of f of b. They are same. Function is continuous and differentiable. You can directly write. Find f dash x, take derivative by u by v rule. Means apply quotient rule of the derivative. Put x equal to c. Then put f dash c equal to 0. Have a cross multiplication. Then product of these two is this. Minus of c square minus minus plus 4c. Product of these two is first 4 terms. Then 4c minus 4c gets cancelled. The remaining terms are there. Okay, you can use calculator directly. You will be getting value of c in decimal point. It is okay, no problem. But if you solve it by, I'll recommend you to use calculator, and you will be getting this value of c. And this value of c belongs to the open interval 0 to 4. Okay, you can get the decimal points value. These are 2 points, not single point. For plus, you will be getting one value of c, and for minus, you will be getting second value of. Okay, this negative value does not belong to this. Okay, but positive value. Okay, but positive value, see, minus 2, positive value means for plus I will be getting value of c, and this value belongs to the open interval. See, here in this interval negative value is not there, but for minus, negative c will be negative, and negative is not coming under. But for plus, one value of c belongs to the open interval, therefore Rolle's theorem is verified. Next problem, fx equal to sin x. As I told you, sine functions, cos functions are continuous and differentiable. Okay, you can directly write fx is continuous in closed interval 0 to pi. It is differentiable in open interval 0 to pi. F of a, f of b, I found these are same. Now for finding value of c, take derivative. I have taken derivative. Put x equal to c, then f dash c equal to 0. Then this, from this c, we want value of c, single value of c, which belongs to the open interval 0 to pi. The c, for c equal to pi by 2, the cos pi by 2 is what? Cos pi by 2 is 0. Okay, you are aware of this. And c equal to pi by 2 is one of the value of c, and this pi by 2 belongs to the open interval 0 to pi, therefore theorem is verified. The next problem is fx equal to this x plus 3 e to the power minus x by 2. Is for convenience you can multiply by x square and 3x. I have written this is the function. Okay, this is the function given to you. Okay, and it is defined on minus 3 to 3. F of minus 3 you can find out. This function is differentiable and continuous. Okay, because this is a polynomial function, this exponential function. Exponential functions and polynomial function both are continuous and differentiable. Therefore, you can directly write function fx is continuous in closed interval minus 3 to 3. Function fx is differentiable in open interval minus 3 to 3. I have not written, but you can write. The f of minus 3 equal to f of 0. These two are same. You can check it. Okay, I left up to you. So you can check it. My f of minus 3 and f of 0 is 0 or not. Okay, same or not. Now take derivative of this. Use product rule here, u into v rule. Put x equal to c. E to the power minus c by 2 is common. Then take LCM as 2. Have a multiplication with this. 4c plus 6. Then 2 multiplied by 0 is 0. Then open the brackets. Then multiply by minus sign. So this, okay, this is the quadratic equation, And find value of c. The value of c you can directly find, use calculator, or you can directly find, because the factors of this are what? C plus c minus 3 and c plus 2. Therefore, value of C are 3 and minus 2. Out of these two values, at least one value must belong to the open interval. See, minus 3 or 0 to 3, 0 to minus 3, 0 to minus 3. This minus 2 belongs to this open interval. 3 does not belong to it. 3 does not belong to it, but minus 2 belongs to this. Okay, the value of C, minus 2, which belongs to the open interval. Okay, it may be asked in as MCQ. Now, very quickly, next problem, this one. Fx here, there are less chances that this type of problem, the splitted interval problems, will be there in the examination, but 2 to 3 problems we will discuss very fast. The function is defined in this interval 0 to 3. Here, in this interval, 3 is absent, strictly less than, and 3 is not there. For this interval, start from 0 and end up to just less than 3. For this interval, this is the value of fx, and for next sub-interval, here 3 is included. 3 is included, see. For this value of fx is 4x minus 5. Okay. Here, the functions having different value after x equal to 3 or from x equal to 3. So you may call this as the common point as the transition point. Okay, the point 3 is not common, but this 3 is there. You may call this as a transition point. So when you check the continuity or differentiability, then you try to check the continuity and differentiability at the common point, or you can say the transition point. Okay, x tends to 3 plus. Okay, x tends to, in which interval x tends to 3 plus is there? And 3 plus means greater than 3. The greater than 3 appears in this interval. Therefore, value of fx is 4x minus 5. That I will be writing here. And put x equal to 3 because we are dealing with the limit. Okay, x tends to 3 plus means what? X is not equal to 3, but x is very close to 3. But that value is close to 3. But on the positive side means little bit greater than 3. So when you evaluate the limit, put x equal to 3 here, and 12 minus 5 is 7. This is right hand limit. Now left hand limit, x tends to 3 minus. 3 minus means what? Value of x is close to 3, but little less than 3, like that. Okay, limit x tends to 3 minus, and 3 minus less than 3 comes under this interval. Therefore, value of fx is this one. And put x equal to 3 here. So before putting value x equal to 3, I have factorized this x square minus 3 square is x minus 3 and x plus 3. A square minus b square formula. A square minus b square is a minus b into a plus 3, like that. And x minus 3 gets cancelled. Now put x equal to 3. 3 plus 3 is 6. Right hand limit is 7. Left hand limit is 6. These two are not same. Therefore, function is not continuous at x equal to 3. So similarly here, in the next problem, in this problem, the 4 is a transition point. The right hand limit I am going to find limit x tends to 4 plus 4 minus, this is what? 4 plus right hand limit and fx here. The 4 plus in which interval 4 plus lies, tell me. 4 plus appears here, means value of fx is 2x plus 4. While evaluating limit, put x equal to 4. 4 into 2 is 8, 8 plus is 12. Okay. Left hand limit is what? Limit x tends to 4 minus. 4 minus comes under here, less than 4, little bit less than 4. And the value of fx I am writing here x square minus 4, and put x equal to 4. Now 16 minus 4 is 12. Okay. And here the left hand limit equal to right hand limit. And when left hand limit equal to right hand limit, and value of the function also we want same. But due to less than or equal to sign, for x equal to 6, the value of fx is what? 2x plus 4. Therefore, no need to find out the value of fx at x equal to 4. Here left hand limit equal to right hand limit. Left hand limit I am writing, right hand limit, right hand limit, and f of 4. F of 4. Okay, the function, therefore function is continuous in closed interval 2 to 6. Okay, continuous in total closed interval 2 to 6. Here as MCQ, the continuity may be asked in closed interval. Okay, now the differentiability I am going to check. The differentiability is I am taking derivative of this. Okay, this I am writing here, because we have a space here. The f dash x I am writing. Derivative of x square is 2x. Derivative of minus 4 is 0. F dash x for next interval is 2. Derivative of 2x is 2. And this is for 2 to 4 and this is for 4 to 6 in this way. Okay. Now the value of the function, differentiability of the function at x equal to 4. Function is continuous in closed interval. Okay, that we have done. See, this is polynomial function. It is always continuous in this interval. This is polynomial function, continuous in this interval. But at x equal to 4, at transition point, I check the continuity. At x equal to 4, function is continuous. This implies function is continuous, fx is continuous at x equal to 4. This we have proved. The function is continuous here in this interval, function is continuous here in this interval. And we were doubtful about at x equal to 4, that we have checked. Therefore, function is continuous throughout closed interval 2 to 6. Now, the function is differentiable in open interval 2 to 6 that we are going to check. Okay. But this is polynomial function. Okay. This is differentiable. This is differentiable in this interval. This is different polynomial function, differentiable in this part of the interval. Whether it is differentiable at x equal to transition point or not, that we have to check. Okay, that we are going to check. Take derivative for this range, take derivative for this range. Now, find f dash x, find f dash of x for x equal to 4. What is it? Put x equal to 8 you are getting. Find f dash of x for x equal to 4. Put x equal to 4, x equal to, means x is not present. Means here f dash of 4 means what? It is slope of the tangent. Derivative is at slope of the tangent at x equal to 4. And here this is again slope of the tangent at x equal to 4 geometrically. Okay, and at the same point, two different slopes are there. Therefore, because at each point, for differentiability, at each point we want a single slope. The slope should not be same, should not be different. Then we have two different slopes at the same point. Therefore, function fx is not differentiable at x equal to 4. Is not differentiable at x equal to 4. The function is not differentiable at x equal to 4. This is open interval now, 4 to 6. What? 2 to 6, 2 to 6. And 4 is somewhere here. Okay, 4 is somewhere here. The function is not differentiable at x equal to 4. Therefore, it will not be differentiable throughout open, because we want differentiability at each and every point. Remember, therefore, function is not differentiable fx is not differentiable in open interval 2 to 6. Okay, because at each and every point it is not differentiable. Accepting x equal to 4, it is differentiable, but at x equal to 4 it is not differentiable, and 4 is one of the point of the open interval. Okay, so therefore Rolle's theorem is not verified here. Not verified. Rolle's theorem is not verified. Okay, so these two sums I have given for your homework. Okay, you try to solve these two, and you can ask me the difficulties in online lecture. So we stop here. Thank you.